Okay, so box and whisker plots rely on 5 pieces of information. So what we've got in front of us here are those 5 pieces of information represented in dots. So the left-hand dot, the dot on the far left-hand side, is what we call the lower extreme. Let me get a pencil. Okay, so this is the lower extreme. That just means the smallest number in a set of numbers. Okay, so they looked at 12 different varieties of flowering plants, but we're only showing 5 dots here because these are the important pieces of information. And what I want to do is I want to find a value that lines up with that. This is very difficult to do on the iPad, but we do our best to draw a line straight down so we can figure out exactly where that hits the number line. So when I take a look at that, I've got 10 and 20. So halfway in between would be 15, 16, 17, 18, 19, 20. So they're counting by ones. So 15 and 2 more lines makes 17. So our lower extreme, the smallest number of blossoms, was 17. The next dot that we see lines up with 20. So that number there is referred to as the lower quartile. So basically what we're doing is we're separating data into quarters. So that's the lower quartile. So that would be the left-hand side of the box that you draw. Now for this assignment, you don't have to draw the box. They're already there. All we're doing is interpreting those pieces of information. Okay. The next one looks like it falls right there. And that would be 25, 6, 7, 8. And that is referred to as our median. So when we had a set of data, 12 different plants, 12 different varieties, we found the middle number of those 12 varieties, and we found that the middle was 28. Okay, that's the median. The next value over looks like it's at 33. And some of these are partway in between, so it may technically be at 32.5, but I want to simplify this so that we don't get caught up in the 0.5s. That's called the upper quartile. That's where the upper quarter of the data starts. And then the last number appears to be at 38, and that is the upper extreme, or the maximum. Okay, that's the largest number that they found. So what we do now is we use those pieces of information to answer the questions asked. So the first one says, what is the maximum number of flowers bloomed? Well, that's your upper extreme. The maximum number is 38. Write the third quartile. That's the same thing as the upper quartile. Okay, those are synonymous. The upper quartile and third quartile are at 33. And then what is the median of the given data? So we identified that. That's the dot that appears somewhere in the center of the box. Not exactly centered, but somewhere inside of that box. And that is 28. Okay, so that is the idea behind finding the median, the lower quartile, upper quartile, and your extremes, lower and upper. Okay, so when we take a look at a long track race, 6,000 meters. Now, this previous problem, she's trying to maximize the number of blossoms. It should make sense that we want flowers that bloom with more blossoms on them. So the idea is to find those flowers that are giving her the best results. What we find with this problem, we want the people that are running less time to finish this race. So they timed it in seconds, And so what we do is, again, line up. And it looks like our lower extreme, and I'm just going to put LE, is right at 790. Now we got to figure out our tick marks. So it looks like the longer tick mark halfway in between 790 and 810 is 800. So each line is counting by twos. Okay, 2, 4, 6, 8, 10, that gives me 800. So this lower extreme is at 792. The lower quartile, LQ, okay, that's the left-hand side of the box. Again, drawing a line straight down as best we can. It looks like it falls directly on 800. So we write 800 right here. Our median, sometimes they refer to that as quartile 2, okay, because it's the second quartile. It's the limit of the second quartile. And that falls right there. So that's 810, 820 is right here. So 2 more lines, 824. Again, counting by twos. The upper quartile falls right here, UQ, and that looks like it's at 830, 840, 842. And our upper extreme kind of looks like it's falling right in between the two lines, so I'm going to try and line that up a little bit better. Let's go with the lower of the two. That gives me 850, 3 more lines, counting by twos, 856. Okay, so what is the interquartile range? Interquartile range means the range between the lower quartile and the upper quartile. So what I need to do is I need to take 842 and subtract 800. And I get 42. Okay, interquartile range just means how far is it from the lowest part of the box to the upper part of the box. Write the first quartile from the given plot. The first quartile is the lower quartile. So this is also known as LQ. And that is 800. And then what is the range of the entire data? So looking at the lower extreme and the upper extreme, which I did not label here, that's the upper extreme. We take 856 and subtract 792. 6 take away 2 is 4. Borrow, 15 take away 9 is 6. We get 64. And that's the idea behind the box and whisker plot, especially when we're just interpreting those. Okay, so hopefully that will help you out.